Hi everyone, welcome to today's virtual chapter, past performance virtual chapter meeting for the month of May. Hope everyone is enjoying their May as June creeps up on us quickly. My name is Leslie Weed. I will be moderating today. For the past chapter, we have our Twitter here, our hashtag, our website, our discussion list, and email. Please feel free to reach out to us if you have questions, comments, or if you're interested in speaking in the future, please let us know. We're always looking for new presenters. If you are unfamiliar with GoToWebinar, there is in the little control panel, you'll see a place where you can raise your hand. I will try to chat with you privately to help resolve any issues you might have. We do recommend that you maximize your screen. That is always helpful for resolution, especially because we do have demos being presented via SQL Server Management Studio. And then for questions, please feel free to type in a question at any point. We will not address questions mostly until the end though, but feel free to get those questions in there and we will try to get to as many as we can near the end of the presentation. And then just a reminder, audio is only available through your computer speakers. We do not have a dial-in number. Okay, quick call out to our sponsor, SolarWinds. They give us a $100 Amazon gift card to give to one of our attendees every month, and this is very generous and really helps us, really get the attendance and give good presentations and find those good presenters for you and topics. Past Summit 2016 is coming up. This is very exciting. If you have never been to Past Summit, I highly recommend it. So lots of technical sessions to go to, lots of people to network with and experts to talk to and places to go and see. We also have a registration discount code, which is coming up on the next screen here. Maybe. There we go. So that is the virtual performance chapter discount code. Please feel free to use that if you plan on going to Past Summit. Again, highly recommend it. It is a great, great summit. Coming up, we have past elections coming up. Hopefully everybody out there is a past member. It is free, so if you're not, please sign up. Elections are coming up and there's a couple little logistics around there. That'll take place in September, but you must be a member by June 1st, so that gives you a week. So make sure you're a member. Upcoming SQL Saturdays, quite a few international ones. Hopefully some of you guys are out there in Iowa or Florida. Those are coming up. If you haven't been to a SQL Saturday, highly recommend that. Volunteering opportunities. Lots of volunteering opportunities out there. Go to volunteers.sqlpass.org. Reminder, stay involved with your SQL Pass community. And this month, we have from the Tiger team at Microsoft, Pedro Lopes, gems to help you troubleshoot query performance. Hi, Pedro. I'm going to make you presenter right now. And we're good to go.
Okay, let me just get the proper screen ready. Okay, let me know if you can see that.
Screen looks good.
Okay, good. Okay, good. So good morning, afternoon, or good evening, everyone, depending on the time zone you're tuning in from. So as Leslie said, our session today is about some of the gems, as I usually call it, that we've introduced into the product, depending on the version, to help you troubleshoot query performance as a whole. So my name is Pedro Lopes, as it was said. That's my SQL handle, my Twitter handle, sorry. My email there if you have questions that you later want to send in, or I'll be making available all the demos and also the deck I'm using today. So if you later run in the demos and you have any questions, feel free to reach back. I can't promise I'll answer in the same day, but I'll answer in a reasonable time frame. So I'm a senior PM in the Tiger team, and I own the relational engine for all in-market versions. I've been with Microsoft over 7 years now, and yeah, that's about it. So the agenda for today will be twofold. The pace will be a bit fast as we have a few demos, but again, feel free to ask questions at the end or send in by email. So we'll first look at a few enhancements we did in terms of show plan warnings. So some of you may already have seen some of these in Service Pack 3 for 2012. We have some more goodies coming for Service Pack 2 for 2014, which is coming up soon, basically the 2016 timeline. We have new show plan warnings. We have corrected a known issue with set statistics IO. We have new xEvents, and I'll share some of those today that have to do with understanding query performance. Now, for query execution and performance itself, we have made changes that allow you to be further aware of when you're running queries that have predicate pushdown, and we want to try to understand what that is. Also, live query stats. My team owns live query stats. Query Store. I'm not going to do a lengthy Query Store demo nor talk about the internals. My team does not own Query Store, but we own Query Store UI. So everything that has to do with the Query Store UI experience and reports and the way you start using the information, I would be very much keen on knowing if you're using other views that we don't expose by default. We already got some good feedback on this in SQLBits, for instance, but as this community is a prime candidate to using these tools, we'll be very much keen on having feedback from you. And finally, plan comparison. This started back in October last year as sort of a pet project, and it's actually grown quite a lot, and it's been integrated with Query Store, so we'll see what's new on that side too. Okay, so let's get started. Diagnostics and management. Well, we'll dive right into new warnings. So, for instance, for sort spills, we don't exactly have a new warning, but we have a lot of new information in a sort spill warning. So a sort spill is basically when you're doing a sort operation that you run out of memory and you have to continue doing the sort, but based on a work table out of 10 TB, which obviously has I/O associated with it, or higher I/O associated with it. So it can be a bottleneck. So these sort spills you can see them associated with a specific level, even if you run an xEvent or a trace to understand if sort spills are going on. You'll see spill level 1. That means that to build the work table, we just needed one pass over the data. So let's say it's the less of 2 evils. And spill level 2 means we had to do multiple passes over the data to sort the data before the sort is complete. Now, up to SQL Server 2016, and that's on your left. I hope you can see that properly. Leslie, can you just signal if you can see that?
Yes, absolutely.
Okay, good.
Yep.
So in the left, what you can see down at the bottom is just this operator used MTB to spill data with spill level 1, and we now know what spill levels are, and this was the order by key. Well, that doesn't really tell me a lot, right? So usually you would perhaps try to extract this query, run in your test server, also with set statistics IO to understand what was going on, right? But in SQL Server 2016 and coming on 2014 SP2, we have this added, so you can see that on the right. We have added information there. So we can see on how many threads the sort has executed. In this case, it was on 12 threads. We can know exactly how many data pages it wrote on the work table and how many pages it read from the TempDB, and also the total amount of grant memory for this operator plus the used memory, right? So you have a lot more information to understand how, let's say, how harsh was the spill or not. Now, for hash warnings, they occur when you have hash spills. So hash spills can be either hash recursions or hash bailouts. So when these have to be, when these don't fit into memory again, they spill to TempDB in an artifact called a work file. So again, you have 2 levels here. Spill level 1 will be hash recursion, And that happens when, so a hash has a build table and a probe phase. So when the build input does not fit into available memory, maybe there was not correct estimations here, we have to split it into multiple partitions, so we have to do hash partitioning. And if any of these partitions are still not available into memory, then we further split into subpartitions. Now, this will lead into a hash spill level 1.
Pedro?
Now, hash spill level 2, yes.
We did have a request if you could just say if you know if these apply to Azure SQL as well.
Azure SQL has the same baseline engine as SQL Server 2016. So that will be yes.
Fantastic, thanks.
So just an FYI, the code that you can run today in SQL Server 2016 has been in operation in SQL Azure for roughly a year now. We always ship nowadays to cloud first and then to box. So that means that we have an added level of testing and assurance when we release new updates. And that's also why we changed the message recently to, on CUs, for instance, to be proactive in installing them. But getting back to the point. So spill level 2 will be a hash bailout, and this happens when you're doing a hash recursion, so you're partitioning, and you've hit the maximum recursion level. So we need an alternate plan to process the rest of the partition data, so that's a spill level 2. So again, it's the worst of two evils, so to speak. Now, going to the warnings themselves, so on the left you can see what we had up to 2016, and that was again just saying, hey, this hash has spilled to TMTB with spill level 1. So that means that we started doing, we needed to do hash partitioning, but we didn't hit a bailout condition. Now on the right you can see what's coming on 2016 and also Service Pack 2 for 2014, where again you can see not only the spill level, but how many threads did it execute. In this case it was just 1. How many pages it wrote and read from TMTB, and also the memory information here. So much more information out of the box, so to speak, when you collect the actual execution plan. By the way, these are only available in the actual execution plan when you collect that. So we've also added new xEvents. Those pretty much serve the same purpose in the sense that it will give you the same information. So up to 2016, we also had the hash warning xEvent, and as you can see on the top, it basically gave you the recursion level which was used and the warning type, again saying what type of hash warning it was and what level it used. Now in 2016 and Service Pack 2 in the bottom, you can see a lot more information. You can see the actual row count that were hashed in the build table. You can see the DOP level that we ran this hash operation. You can see the granted memory, the thread ID. I mean, you can see a lot of information even from an I/O perspective there. So again, that goes and a great deal to help in troubleshooting issues with hash spilling, to understand exactly how much of a bottleneck can a specific hash warning be or not. So in sort warning, similarly, in the top you can see what we had up to 2016. So that was just saying, hey, we had a sort spill, and here's the sort level, so sort spill level, not much more. And at the bottom again, we can see that in 2016 and Service Pack 2 for 2014, we have a lot more information there, right? Okay. Now for hash spill specifically, we have a new xEvent, and this one will be triggered at the end of the hash processing, meaning when the hash join or aggregate that need to spill finishes, then we get some added details here. So again, pretty much the same information, but you can use this together with other events to determine exactly which operation inside a specific plan is causing the hash spill, just based on xEvents alone, without collecting the plan. So for my first demo here, I'll actually just, so you can see my screen, I trust. And what we have here is a query that will generate a hash warning. Why is it opening again? Okay. Now I'll use the well-known AdventureWorks 2014, so you can run this demo yourself. Just going to do some quick setup here. Yeah. Now I'm going to create an extended event session. And as you can see, I have the hash warning event, but also the hash spill details event. I'm running this only out of memory, so hopefully, what? Oh, yes, of course. I have this. Okay. Okay, so let's see our session here. Oh, come on. Okay. So, okay. Now what I'm going to do is clear the cache and just execute this specific stall procedure with a couple of parameters here. Oh, actually I should have, yeah. Let me do something else now. So I'll start this. Okay, I'll watch live data. Hopefully, because this xEvents caches information, I'll be able to see it right after the execution, I hope. I may have to run it more than once because this is can take some seconds to sync here. Let me run it just again. Okay. So let me just stop the session right now. So we've captured, yeah. So I've run it twice. Here are them. So the hash warning, we can see that when I execute it with ny parameter, this is information I get from that spill. So I now get how many rows were hashed. It was executed in just one scheduler. I know how much memory was granted to do this, but only so almost all of it was used. So this also means that for the estimations that were needed to be done after starting to spill, actually we were pretty close. We had a hash recursion here, so the recursion level is 1. And you can also see how much IO we did on the work file level, so on TempDB, 32 page writes. So in the hash spill details, you can see some more information. Namely, you can see more information about the IO. You can also see the thread ID in which it ran, and basically that's it. So carrying on, let me go back to my other one, the sort warning. So let me create another session here. Okay, let me start this. So again, this will be running a query in AdventureWorks, so something you can also do for yourselves. Okay, so let me run this. Hopefully it will sync fast enough. Oh, I didn't check the actual execution plan, but let me do that right now and run it again. Okay. It will come. So looking at the execution plan here, we can see a sort. Oh, actually, this didn't spill. Huh, interesting. So the demo gods are not with me today. Interesting. Oh, I have a lot of memory in this server. That's why. Okay. Well, in the sake of time, let's just move on. I'll move on to the. So about memory grants, and this is an area we've invested quite a lot in making more transparent what's going on inside the covers. So memory as a reservation is essentially we need to reserve memory before starting to execute any query, right? So that is a memory grant, and that memory grant, the size is determined by the cardinality estimator, meaning we derive the cardinality estimation. With all that metadata, we make a assumption of how much memory you're going to need, and we ask for that grant. So if memory is available, the query eventually gets that grant, it starts executing. The thing is, the initial grant of memory is final, meaning if it was poorly estimated, such as we saw in the case of an hash warning or a sort warning, they will just spill to this because there's no more memory available for that query to execute. Now, for instance, the example right there has to do with the query execution gateways, and in the big gateway we now allow up to, well, an indefinite number of queries to go into the big gateway depending on the available memory. The thing is, any query that goes into the big gateway can take up to 25% of the entire resource pool, so entire available memory in SQL Server, which can be a lot. These are just for big queries. But the thing that happens is, if we have insufficient or we have inadequate estimations, that means that we can provide or reserve a lot of memory and then don't use it. So this leads to inefficiency memory usage. This leads eventually to a lot of spills. That's why we may have extensive 10TB usage. Those are harder to diagnose in nature, and we don't have that much of a concurrency because we now have what we estimated would be big queries, and we can have less big queries running concurrently, and that will also hurt concurrency in the engine. So what we did to mitigate was to begin with, we have some new query hints. So we can actually force the mean grant percent and the max grant percent that a query is allowed to run. And this is a percentage value. The query is guaranteed to get the max of either the required memory or the mean grant. And that's because, so the least will be, we need a specific amount of memory to start the query. So if the required memory is less than the mean grant, we will obviously take that instead of the mean grant if the mean grant is too large. So when I'm saying too large, it's because it's obviously in percentage. And let's say in this case, I'm setting the mean memory grant percent to 10%. But if I'm using a 1 terabyte memory server, that will be quite a lot, right? And the query may not need for a specific execution to acquire the mean grant. It will maybe be able to execute with far less memory. So if the required memory is less than the mean grant, we'll just take that. So we've also added, to diagnose this, we've added new extended events. New extended events both in the analytic channel but also in the debug channel. We have new and updated DMVs, and we also have runtime information in showplan XML, and I'm going to show some of that now. So the min and max memory grant options, you can use that. It's a query hint, so you can use it in the option clause. The max grant percent needs to always be larger or equal to the mean grant percent, and the valid range is a decimal value between 0 and 100%. Why do we have a decimal value? Well, this is because obviously if we have a very large server, we need to go below 1%, for instance. So we need to have more fine-tuned control here. So yeah, that's why we're using a floating point. Now this is available in 2016, but also in Service Pack 2 for 2014. So it will be readily available in a few weeks. And in terms of the DMV, so in SysDM exec query stats, we now have these new columns here. So it's all about the memory usage for a specific execution. We can see the total grant, we can see the min grant and the max grant, we can see even the the last used memory grant or the total used memory grant. So we have a lot of information here about memory usage for a specific query. Now the show plan also has new information. So in this screenshot here, we can actually see that the granted memory was about 780 megs, but the used memory was just 0. So actually we didn't even use 1 megabyte of memory to run the query. So this is obviously a misestimation running here. Now let's take a look at these. So what I have here is, let me open this. Yeah. So I'll create a new event session. Actually, I already had it here, so that's from the previous demo. I'm going to, let me open the other one. Yeah. So I'll just start the session. And I'm just going to run a query here that will have some inefficient use of memory. So it will run in a loop, so we'll be able to see it. Yeah, here it is. So let me just stop it. So let me choose either one. So what we can see here is the query text. We can see the database name, the DOP in which it ran. So we have the granted memory in kilobytes. And we can see the query hash, the query plan hash, so we can retrieve this information from DMVs, for instance. But you also can see the use memory kilobytes. So we can see between the granted memory and the used memory, there is obviously a huge skew. This is inefficient use of memory, obviously. So this has to do with estimations that were made to run this query, and in this case specifically it has to do with some heuristics because you're running an XML query. So bottom line here is you can detect from the xEvent alone if you are running into this kind of issues where maybe you have lower concurrency, maybe you have queries that are being given a lot of memory to execute, but in the end they use very little. So detecting these patterns is very useful for you to either refactor the query or understand how to improve estimations as a whole for that specific execution. Okay, so going back to my deck, still in the memory grants, we have also done some work to address large memory grants when they are requested for specific operators. So when you do a join based in a nested loop, the join can be something we call an optimized nested loop or a batch sort. This is basically an optimization that is used to effectively minimize the I/O that the engine may take to resolve that specific join. So what it happens is the nested loop may try to reorder the input rows to improve the I/O performance. So the issue is, and the issue we found is that sometimes we can have a huge or extreme memory grant when the outer table of the nested join has a predicate that will filter the result in a small input, right, to a very small input. So what happens here is a case pretty much, if we use the extended events I just showed, pretty much we will see that huge skew between the granted memory and the actual used memory. There are options for this. For example, in KB that you can see on the screen right now, we had an option to disable this feature, so the optimized nested loop globally using the trace flag. We also have new query hints, and I'm going to show some more of that right afterwards. So what are the side effects of these extreme memory grants associated with optimized nested loops? Well, there can be several. You can see resource semaphore waits. You can see some of your caches being evicted quite often, which is triggered by memory pressure. So that will also lead into more I/O in your server. And you can even reach out-of-memory conditions. We've seen this in a couple of examples in machines that have over a terabyte of RAM, for instance. So in SQL Server 2016, we've actually changed this behavior globally using the trace flag 2340, as you can see here. Now we're also porting this behavior back into 2014. Sorry, and it is the ability to self-regulate these extreme memory grants. So let me show you that. So the demo actually here is not a live demo. I've previously captured an extended event session with this information. So the demo you'll be able to see is just a comparison of a couple of execution plans. So one is running in SQL Server 2014 Service Pack 1. So let me open this one. And the other one is running in, was executed in 2016 RC0. So as I just said, this optimization is also coming for Service Pack 2 for SQL Server 2014. Now, this is exactly the same query as we're going to see. So on this side we have the 2014, and let me just open the properties here. Yeah. So opening here the memory grant info, what do we have? So we see that the granted memory was almost 700 megs. Now the thing is, it's only used 176 kilobytes. So there is a huge skew in certain query patterns. So this is an optimized nested loop. And yeah, let me just show you. Yeah. So when you have this sort of information here, you can see that it's a optimized nested loop. So what you can see is there was a huge skew in memory usage. So let's see what happens with the new optimizations that we've built into the engine. So memory grant. So we can see here the CE version was 120, and here the CE version is 130, and the granted memory was just 1 megabyte, and the used memory was pretty much the same, so 200 kilobytes. So you can see there is these optimizations made it into the engine in a way that it will allow you to scale up much better. You will not have these inefficiencies that can be associated with extreme memory grants in optimized nested loops, and this will allow you to execute more queries concurrently. Okay. So moving on. So we're still going to discuss memory grants, and that is, we also are pushing out a new memory grant show plan warning. And this will be in 2014 SP2. It will not make it to the RTM version of 2016, but we are very hopeful that we'll be able to make it in the first CU after 2016 ships. So to detect some conditions associated with these phenomenons of granted memory versus actually used memory, we're coming out with a warning that has 3 conditions. So a warning can be triggered if we are underusing memory, which is just the case we've seen here. And this is when the max use size is very, very small compared to the grant size, right? So the thing is, if you have a lot of queries running with a larger grant size, you are causing blocking because you cannot run other queries, so you have less efficient usage here. Now we also have a condition which is if it's overused, meaning if the used memory exceeds the grant size, and this will obviously lead to spills and whatnot, but this can actually cause out-of-memory conditions on the server. And then we also have a dynamic condition, which we call excessive growth, and this will happen when the growth between the initially used memory starts growing very fast closer to the granted memory, and if this growth is this memory grant increases too much, then this can lead into server instability, and therefore we also issue a warning. Now this one is based on some heuristics, so just use this with a grain of salt, in a sense that you need to go in and analyze if actually this type of warning had any nefarious effects in your server. Okay, so we also did some call it a fix. Actually, this is addressing a very old Connect item, which is set statistics IO did not show workload statistics coming from source, worktable statistics, sorry, coming from source. So as you can see in the top, up to 2016, if we were running a query that had a sort warning and you were running set statistics IO, you would not see the information regarding the worktable to support that specific sort. And worktables can be used for a variety of reasons. In this case, was specifically for sorts. So in 2016 and 2014 SP2, we've actually addressed this, and as you can see in the bottom, we now have statistics being output for these worktables. Now, another very old Connect item, actually opened by Ola Allengreen, I believe, was coming from an issue. So someone that looks at xEvents and tries to correlate those with DMVs, they always had an issue, which is the query hash and query plan hash actions in xEvents, such as we've seen today. Those were not the same data types as their respective columns in several DMVs. So this made it kind of difficult to correlate the information if you needed to. There are solutions out there, namely using CLR, but the thing is we didn't have a native solution for this. So in 2016 and 2014 SP2, we now have these new actions that you can use in your xEvent session, and these are query hash signed and query plan hash signed, and this will allow you to join those DMVs with the xEvents because they are of the same data type. So you'll be able to correlate properly. Now, what else do we have? So am I doing on time, Leslie? Okay. Some other enhancements we've done is to add per operator level performance stats. So what do I mean by this? So it's usually when you have a query performance issue, you may yourself or ask someone that's handling the issue, ask them to retrieve the actual execution plan. Now, the actual execution plan needs to be a rich source of information, so that you don't need to go back and forth a lot of times to collect further information and just over time extend the process of troubleshooting a query. So that's why, in line with what we've already seen today, we're adding more information into show plan XML. So up until 2016, you can see in the top, the runtime information just included information about how many rows were being moved through a specific operator, scans, how many executions, and that's about it. Now, in SQL Server 2016 and Service Pack 2 for 2014, in the bottom, you can see a lot more information added. You can see the actual rows read, and we're going to talk a little bit about this going forward. And we see the actual rows. So in this case, there's actually a large skew between the actual rows and the actual rows read, and we're going to talk about this in a few minutes. You can see also the actual execution mode. It can be row mode or batch mode. You have the elapsed milliseconds. You have the CPU milliseconds. You have also I/O information. So natively, when you collect a actual execution plan, so show plan will already allow you to have enough information to have working hypothesis as to where a bottleneck for a specific query may be. Now, there's also a new extended event that basically has the same information. So if you're running an xEvent trace, just bear in mind that this one specifically sits in the debug channel. So it's not meant for you to run all the time, as this may cause performance issues, in the sense that if you have a very resource-heavy workload running and a lot of queries running, if you are collecting this amount of data for every single query, imagine as it would be like almost collecting part of the execution plan for every single query live. So do account for that. Just a caveat here, which is the show plan time scale for the same events is in milliseconds. but for CPU and total time in the X event, it's shown in microseconds. Just for you, if you try to correlate information, just bear this in mind. Okay, so let's see what we can find in this new artifacts. Okay, so yeah. I'll create a new event session. Oh, I didn't stop the other one, so let me stop that. Okay, so I have it here. Let me open another query. And I'm actually going to collect the actual execution plan on this one. Let me get this running. Watch live data here. And let's execute this. Okay. It will take a few moments to sync. So let's look at the actual execution plan here. So you may notice that so that information should be here in the properties. We cannot, so SSMS is not parsing that information. We are addressing that for an upcoming version of SSMS because this is SSMS only. So what you can do is just right-click and actually look at the plan XML. So in the plan XML, you'll see a lot of information. So this is the memory grant information I was referring to earlier, and this is actually exposed in the properties window, as we've seen. But now, let me go further down. Yeah. So now we have, so these are running time counters per thread. Let me see one that is more. Okay. So for instance, let's look upon this one. So run time counters per thread. And this is coming, let me, okay, this is correct. This is another one. Sorry, too many windows open. Let me just close a few of these. Okay. And I may have closed the wrong window, haven't I? Yeah, I did. So I need to run this again. Come on. Okay. So this will be node ID 3. I want to look at node ID, okay, 3 and 6. Good. So let me look upon this again. Let's look at node node ID 3. Here it is. So what you can see for the runtime counters per thread, this was running in single thread, and that's just to be simpler to look at. If we were running this in parallel, then we would see one of these entries per each of the threads that was running. So what we'll be able to see is the actual thread ID, the number of rows that actually was output, the number of rows read. So in this case, there's no skew here like we've seen in that screenshot earlier. The number of batches, the actual execution mode, the task address, the scheduler ID in which it was executed. And then you have the times here in microseconds. So, sorry, the milliseconds. So the actual execution, the actual elapsed time, actual CPU, so a lot of more information that you didn't have available before. So if we, oh, this is not here yet. Oh, come on. Yeah. So this is the issue with doing a live demo with xEvents, is that we may need to wait for it to sync. Let me do it again and see if it comes up. Okay, here we are. So we were looking at node ID 3 before, right? So it's actually the one I have here. So I can correlate the information I get from the xEvent with the plan if I have the plan stored. So in this case I can see again more or less the same kind of information. So the execution mode, I can see the actual rows, I can see the CPU time, but in this case it was in microseconds, so I can see that it was less than 1 millisecond. That's why I was showing 0 in the show plan. It's because SSMS will round up to millisecond. I can see the plan handle, which then I can retrieve the plan from cache, for instance, and compare some from a visual fashion what's happening there. I can see the new signed for this new sign for the xEvent, so I can correlate this with my DMVs. I can see the scheduler, the session ID in which it ran. So a lot of information coming from the xEvent, and very, very similar to the one I can see in execution plan XML. Okay, so moving on, let me just close the windows before I get into this problem again with the next demo.
And you have 15 minutes, just to let you know.
Okay, thank you. I think that should be good. So earlier I called your attention for that screenshot where we had quite a large difference between the rows red and the actual rows and the actual rows red, and that may happen because of predicate pushdown. So predicate pushdown is actually an optimization where if we have a query that has, so where part of that filter predicate matches an index key, we can use that to run an index seek or range scan. That means that all the parts that were known are the residual known as a residual predicate. They must be evaluated for each of the row outputs, and then what you would see is that after that index scan or that seek, you would see a filter operator to do this residual scan. So to improve performance, what we do in SQL is that we push that filter down to the table operator itself so that we are able to optimize I/O. But the thing is, if there's inaccurate cardinality estimation, let's say we have a parameter sensitive query, then the scan filter can be processed at a larger number of rows than is expected. For instance, as we've seen in the screenshot earlier, we're only returning 8,001 rows, but we actually read over 1 million. So you had actually no visibility before the enhancements we are introducing now. So this is, in the case of the actual execution plan, this was actually hidden because you would only see the actual number of rows returned after the residual predicate has been applied. So it's not the actual number of rows that are scanned from the underlying table or index, right? So if you have rows being filtered out by the storage engine, how can you find that? And those could be confusing to look at. For instance, you may look at a plan that's seemingly simple, and for instance, you were seeing a index seek that did not have a lot of actual rows output, but you were seeing a lot of CPU usage or a lot of I/O if you're running a trace over your server, a lot of I/O coming from that query. But the query plan and the actual execution plan did not reflect that. So again, it would be a case where you would collect the execution plan. Some would say, okay, but when I execute this, I'm also taking a lot of resources. You would need to go back and forth to try to understand where the issue is coming from. So there's a new show plan attribute called number of rows read. And so what this attribute does is actually show us the difference we've seen before, which is show us the actual number of rows that were scanned or seeked in the underlying operator when the predicate was pushed down. And this was already in 2012 SP3, it's coming in SP2 for 2014, and it's also coming in 2016. Now, for the sake of time, I'm not going to do this demo. It's just a query over AdventureWorks. You can run this, and you can see the difference between. How much time do I have? not a lot. So I need to skip this demo specifically. Just to show you what we have here, you just run this query, and you will be able to. So once you see this, you'll see that one query is actually pushing down the predicate, and you will see that optimization being done by the engine, and the other would not. And this one would be specifically because of the conversion we're doing here. So I'm just going to skip this demo for sake of time. Okay, so carrying on. So we've been talking about query performance. Now there is a perceived issue with understanding how to troubleshoot long-running queries, or queries that actually never end. For instance, recently I had a case where a customer was running the same query for over 30 hours. They actually blew up 10 MTB, and we could not collect the actual execution plan, right? So the issue is we have very limited feedback for query execution progress, right? And this would make it very difficult to get insight into those scenarios. Now, we already have a lot of information in the actual execution plan, but estimated execution plans don't have that runtime information that will allow us to quickly get into a hotspot in my execution plan. So enters live query stats. So the scenario would be ability to tap into the execution process as the data flows from one operator to the other one. And well, I'll show you this in a moment because the picture is obviously worth more than 1,000 words. And it will also facilitate some self-troubleshooting of those long-running queries. If you find a problematic operator, you can add indexes, maybe you can update statistics. If you see large skews, you can use a full-fledged of techniques to try to improve performance there without necessarily having to call Microsoft support. So using live query stats implies that you have to enable statistics profile infrastructure. So this is an underlying profiling infrastructure so this is not to be confused with query profiling in the classical sense of the word. It's an underlying infrastructure that needs to be enabled in order to get information about what's executing. So specifying to include live query statistics in SSMS will enable by default this infrastructure for that query session alone. So it's not enabled for the entire server because as it stands now, it has some performance impact if you enable server-wide. So the data is stored in this DMV, this is the MXEC query profiles. And you have three other ways to actually enable this statistics profile infrastructure. And that's to be able, if you want to use live query stats to look at information not from your session but from other sessions, for instance using Activity Monitor, you need to enable either set statistics SML on, set statistics profile on, or enable the extended event you see here, which is query post execution show plan. Again, these are server-wide settings that you would need to enable, but again, I would advise that this will have a performance impact. Now let's see how useful can something like live query stats be. Let me just pull up this. So what I have here is it's a very, very large query. Let me just clear this. Okay. Let me enable, so include live query statistics. So I'm going to just enable for this session specifically, or I could have done that with set statistics profile on. I mean, I have a number of ways I can do that. Let me just make sure I'm in the right database. Okay. So as you can see, a very convoluted query here. I'm actually forcing the old, I'm actually forcing the cardinality estimator version here just for demo purposes. So as you can see, as we start a very long-running query, we obviously still don't have access to my actual execution plan, but I can see as the execution progresses where a possible bottleneck might be, right? And I can already see very huge numbers in the works here. So for this nested loop already has billions of rows, and they exponentially grow up here. So as you can see in this case, the estimations are way off. Obviously, this is a fabricated example. I'm purposely using the old CE for a case where the old CE would have very poor estimations. But as you can see, this could be pretty much a live example where you would be able to actually see where the bottlenecks are, stop the execution, and just be able to troubleshoot the query as it was running, right? So it's very useful for these scenarios here. You can see some warnings, for instance, that we have some implicit conversions. Those will affect cardinality estimation. I'm doing those implicit conversions in several places, so I already have some go-dos here that may improve the performance of this query, and then obviously try again. Okay, so that was that brief example on that. So we may run over for like 5 minutes, but I hope it's no more than that.
Sounds good.
Okay. So we just saw one problem with query performance, right? Which is long-running queries, and you can actually take some action and get some insights with live query stats. But what about getting insights in your production environment as it is running? So usual problems with query performance could be, hey, my website is down, and that may mean that the database is not working or not responding. I may have temporary performance issues where users are complaining with not a very predictable pattern that sometimes the application is not responding correctly, and you start to see that's the issue actually with your database server. You need to answer questions like, why is the query so slow? Why did I have a previous execution plan that worked better than this one? A classic example would be I've upgraded my database to a new engine version, and because in each engine version there are improvements, but as all improvements that run over millions of workloads, you can see occasional regressions. So if in the case you see specific regressions after an upgrade, well, that's actually the point where in previous versions you had to put into action your rollback plan, eventually roll back the entire migration or upgrade until you could sort out the performance issues coming from regression when you change engine version. Well, these are some of the aspects that we've addressed with Query Store. So you can be very tactical, meaning you can be very specific in finding and fixing specific planned regressions. But as you run Query Store over your databases, you can actually also identify trends like the top resource consumers. You can use this information in Query Store obviously to reduce the risks with server upgrade, so you will have better understanding of your workload and how to quickly address those regressions if they come about. And you can be very strategic, like you can actually retrieve and analyze workload patterns as they are being stored by Query Store. So basically, this is our, let's say, recommendation for an upgrade workflow. And that is with the purpose of maintaining the query performance stability to a familiar point when we're upgrading. So that means that we would, let's say, install the newer version of SQL Server. We are actually talking about upgrading from any current version to 2016, for instance. Let's say I'm upgrading from 2012 to 2016. I would install the bits. I would move the database over, but I would need to keep the database compatibility level at the level of the source engine. Now, what I would need to do is enable Query Store, and afterwards just run my workload, meaning whatever is your business cycle that's relevant for you to collect data to be your baseline, just let it run. And you are running that workload with the same compatibility level that now very much restricts the engine to even determine cardinality estimation to a specific version. So it will be a very very similar performance point that you'll have. And then you would later, after you've created that baseline, move your database over to a new compatibility level, so 2016 compat level. Afterwards, you would be able to if you saw specific regressions, because you have that baseline, which is the query plans as they were executed in the known good dbeat compat level. Now, if you saw specific regressions, you could just, with 2 clicks, address those. So this would be the appropriate workflow that we recommend when moving to 2016. Now, about the UI, because I told you my team owns the UI experience. You have a lot of options here. I'm going to show you some of them. And part of that, part of a Query Store is SSMS plan comparison, which is the ability to, let me go back one screen. So as you can see, for instance, for this query, I have 2 plan IDs. So you can see them here. I'm able to select both and select the compare plans, and this would bring in this UI, which allows me to understand the differences between the plans. Now, I could have, and let me go back, I could have just easily said, okay, this is a regression, I have here a plan that I know works properly, and this is maybe in an upgrade. This was the version that I knew that worked better, so I can just click it and click on Force Plan. But I want to understand what changed, right? So this is where plan comparison comes in. I can use it both within Query Store or standalone, and I'm going to show you that. So we have a lot of new information here. We have the properties window where you can see it's highlighted to you the differences between the plans that you're comparing. In this case, we have a bottom plan and a top plan, and you can see where the differences are. One of them is currently was executing in the old cardinality estimation version, the estimator version. The new one is actually executing in the 2014 cardinality estimator version. And you can see a lot of information here about how to navigate through the plan. Now, this was also used to revamp we also had to revamp the entire show plan analysis experience. We have to do things like improve the UI in a way I'm going to show you next. Now, what are the customer scenarios? I need to find, for instance, queries or batches that suddenly slowed down. I need to compare them with the previous state to really get into deep into why the change happened. This is still not replacing your skills as a DBA or developer to understand where the issues might be. We're working to get to that point one day, but it will now give you to your face, let's say it like that, where are the potential hotspots that you have. You also can understand the impact of a query refactor. Let's say you've refactored a query, you want to compare to a previous state where you had the execution plan. Or you want to analyze, like you've created new indexes, for instance, and you want to understand how that is impacting your plan by comparison with the old plan. So you can use that to, in the same screen, look at comparing 2 different plans. Now, Plan Compare is available not only from within Query Store, but actually you can do this offline comparison because it's a feature embedded into SSMS, which means that, first of all, you are not bound to a specific SQL Server version. You can compare plans between several SQL Server versions. You can compare plans from 2005 and 2016, for instance. So it will allow you to find either differences or similarities, and we'll go into that. It will allow you to look at the plan shapes. And these are important to understand, let's say, not only from a cardinality estimator perspective, but let's say you created new indexes and you want to understand how that impacted even the overall shape of the plan, because the order of the operators is important here. It will also allow you to analyze the properties between plans for one specific operator to see how it was affected. And it also has a rich set of user options that we're going to take a look at. So just a quick note here before I go into the demo, and I know I'm already 4 minutes over, so bear with me if you want just 5 more. We had to change some baseline, let's say, experiences with SSMS. We had to enhance the plan real estate. We added mouse-based zoom control, so you can just use your control key and your mouse wheel, and you'll be able to live zoom. If you're in the context of plan comparison, actually the live zoom is simultaneous between both windows. You can also just click and drag the navigation instead of using the scroll bar. So we have to enhance this experience here. So just an example, this would be a plan where you're looking at a distro plan up to 2016, SSMS 2016. You have a lot of vertical lines. In the new version, we've optimized this to have a more condensed view. So if you zoom out, this would be the aspect of this plan in SSMS up to 2016. So very long vertical lines, very difficult to navigate around, and this is the new experience here. Right. So let me go into the last demo. So what I have here is a database which I fondly called Query Store Test. It's not this one. I will not go. So you have in here you'll find the demo here. It's an app that generates some workloads. You have a backpack for this specific database, so you can restore that. There are some parts of the demo I'm not going to run, which is showing some basics around where is data stored. If I have different kinds of queries like head-hoc queries or store procedures or triggers, how can I explore that within the context of Query Store? Those are all here. What I'm actually going to focus is just running a workload for us to explore the plan comparison within the Query Store. So just getting my server name, you'll need to set your server name here. In this case, I want to run the regression workload, so I'm going to hit R. Yeah. So let it run for a while. You should immediately start to see data being collected. So in this case, in the scope of Query Store Test database, if I go to properties, I have, come on, bear with me, I have a page called Query Store, and I have several configurations here. And I'm actually collecting data already, so I can set a limit. I can set the Query Store capture mode. I've set it to all because I just want to capture everything I'm running now for the sake of the demo. But you can actually just say auto to capture only the queries based on very high resource consumption, for instance. This would be very good to create a baseline, for instance. You can choose to clean up whatever is the max size for Query Store automatically, or you can choose to not clean up, which means that once you run out of space for Query Store in the configuration you've set here, that means that you stop collecting query profiles, right? So bear that in mind. So let me cancel this. So inside the scope of my database, I'm going to the top resource consuming queries. And what I can see here is a top consuming query. So I have two plans here, as you can see. Plan 2 is the one I'm seeing now. Plan 1 has an example here where it ran very fast. So I have two execution plans for exactly the same query. So what I want to do in this case is actually, so I've just used my shift key. I've selected two plans, and I'm going to compare the plans for this query. So this brings up the experience for plan comparison. Let me just create some more room here. Okay, what do I have? So I see estimation differences, for instance. So the top plan, which is the table scan, is estimating 10,000 rows. The bottom plan is estimating 1 row. So if I go further into other, well, in this case I don't have any matching operators top and down, so only the select node would actually be relevant in this case. But I have, for instance, the set options. These are not different because otherwise I would have that signal here. But what I do have, and again, this is something we're addressing in the future, so in any property that has sub-properties, we are not checking the differences between them. We're going to address that in a future version. But what I can see right here is that I had different compiled values for these queries, and that's why I generated two different plans. So this would be a classic case, for instance, when you do an upgrade, and I could understand what was my baseline. The baseline I knew that was working properly. I could go back into here. I would say, okay, the plan I want to choose as my baseline is this one. I'm just going to click here and force this one, and boom, it would just execute with this specific plan, disregarding the other ones. Now, and this will be my final part. This one didn't really show you a lot about plan compare. So what I'm going to do, let me just stop this. Okay, what I'm going to do is pull up offline comparison of plans here. So I have a couple of plan pairs here. Let me just open this one, for instance. So, okay, come on, we'd open another window. Good. Okay, so I have this. So how can I pull up the other plan? Well, I need to right-click, compare show plan, and it will ask me for where the other plan I want to compare with, where it's at. So in this case, I'm going to compare this one, open, and I can see plan comparison right now. So by default, it's highlighting the similar branches, the similar operations. And that is a configuration you can set here. You can also set it to highlight the non-matching operations. So this is a very simple plan, but in a very complex plan, you'll be able to spot the differences. Let's say we have also added this option to ignore the database name, because let's say you have a production, a plan you collected in production, and you have another plan that you collected in your test server after doing some enhancements. You want to compare them. If you are using so we disregard the fully qualified name, so the database name part of the fully qualified name, in order to do the comparisons. And when we click in the context of a matching operator, it immediately comes into scope, and we can see where the differences may be. In this case, it was the actual number of rows coming from those is different. If I click on this one, I actually see the difference is quite huge. I can also see the number of executions was very much different, and the number of rows read. So again, in this case, it was the same, so I did not have any predicate pushdown skews here, which is something I'm leveraging the new, to see this, I'm leveraging the new show plan article here. Now, what else do I have? If I had a lot of similar areas, I could just click here and I would jump into that specific area. I can move around, as you can see with my mouse. I can use my live zoom, and it's live zooming in both plans. So you can do a lot of this, and again, it's completely offline. You can do this with several versions of plans, so from 2005 to 2016. Okay, I didn't run.
Just
Sorry,
a little.
I took a lot of your time. So I have the deck and the demos already up in this URL here. There's also a survey there. I apologize for the pace of the session. I had a lot of content to cover, and I still ran 12 minutes overboard. But I hope it was useful for you, and I'm still around to address questions at this point if you still have that. Or again, you can use my email and send those in.
That sounds great, Pedro. We have one question. Do we have any overhead or side effects using a cached plan from the Query Store instead of the actual new plan?
So the thing is that I'm not sure if I understood the question about overhead. There is, you're basically collecting, at this point in time, you're collecting a plan that still lacks some of the runtime information that we have available. This Query Store is using essentially xEvents to collect some of this data. So it's lightweight, but we are improving the ability to run this with very, let's say, demanding workloads. But to be very specific to your question, we have not seen performance regressions that are more than a couple % in very busy servers. But then again, your mileage may vary.
Okay, thank you, Pedro. One quick comment. Somebody early on said, "Thanks for the VLF fix script. Great value."
Oh, my pleasure.
Okay.
Okay, thank you.
Sounds great. I'm going to end the recording right now, and this will be up, so you guys will be able to get to this from the website, the recorded version, and of course Pedro's link to that